Alrighty, so we're going to build on our idea of oxidation numbers that we talked about last time and get into um, actually looking at, maybe analyzing, thinking about um, redox reactions, right? Oxidation reduction, we can also call this guy redox, which happens a lot because of, you know, lazy chemist's mouth or whatever you want to call it. Um, anyway, every redox reaction has a transfer of electrons. Okay, so this is why we need our oxidation numbers, our oxidation states, so that we can keep track of where the electrons are and where they were going and all that fun stuff. Okay, so what we're going to get at in this video is talking about the processes themselves a little bit. We're going to talk about half reactions and what that means and how to deal with that. And we're going to talk about what the agents are that are doing all the work. Okay, so let's just dive right in and see what we're talking about. Okay, for oxidation reduction, there are two processes that are happening at the same time. One of them is oxidation, and one of them is reduction. So let's think about oxidation first. Okay, it's called oxidation because back in the day, this was um, studied or discovered or figured out because the element became oxidized because it picked up oxygen. Okay. Now we know what's happening here in an oxidation is we're having a loss of electrons. Okay. Another way to think about this is you're having an increase in the oxidation number or the oxidation state. Okay. On the other hand, we have the other process, which is reduction. Okay. And in a reduction, sometimes it's thought of as picking up hydrogen. So when we get into organic chemistry, we talk about picking up hydrogens and adding hydrogens to stuff is reducing the molecule down. Um, what we really mean here is the reduction is a gain of electrons. Okay, this means we're having a reduction. This is how I try to keep it straight. A reduction in the oxidation number. Okay. The reason all of this electrochemistry, all of this redox stuff feels backwards is because electrons have a negative charge. Okay. And there's all kinds of mental tricks you can play on yourself. This is the way I think about it, is I always think about it as in the reduction, you're having a reduction in the oxidation number. So your oxidation number is going down. Okay, which means that in the oxidation, your oxidation number has to go up. Okay, there are other tricks, like over here, Leo says GR, right? Uh, Loss of electrons is oxidation and gain of electrons is reduction. Um, Another one I learned is oil rig. Oxidation is loss. That you can't see that. Oxidation is loss of electrons. Reduction is gain of electrons. Whatever's going to help you think through this, latch onto it. As soon as you figure out what clicks in your brain, latch onto it. But there's lots of ways to think through this. All right. Once we know what our processes are, what we need to be able to do is, can we identify what a redox reaction is? Okay. Our big rule here is that we must have changes in oxidation states during the reaction. Okay. So we're gonna have to figure out what the oxidation states are and things to be able to do it. This is why I said that was crucial that we knew what our oxidation numbers are. So let's go through this and just kind of figure out what they are. Okay. Hydrogen in the front is +1. We have Br, that's -1 because 1 and 1 has to cancel out. Calcium is in group 2, so that's a +2. We said oxygen has to be -2, and hydrogen is going to be +1. And we can figure this out if we're so inclined, because hydroxide has to be OH-, right? So If the oxygen is -2, then the hydrogen has to only be +1 to work through that. Okay. Now to the other side, hydrogen in the front is +1. Oxygen has to be -2. This calcium is still +2 because it's part of the ionic compound. And then we have BRs over here to balance it out as -1. Okay. So what we want to do is we want to look at each element and see, does that element change as it's doing stuff? So hydrogen is +1, +1, and +1. So the hydrogen didn't change. The Br is -1 over here, and it's -1 over there. So that didn't change either. Calcium was +2 over here and +2 over here, so that didn't do anything. And our oxygen is -2 here and -2 there. So this is not a redox reaction. Okay. Again, this is something that as you get more comfortable with the oxidation states and oxidation numbers, that this will come um, hopefully quickly in your brain. All right, so let's look at this one. This one, we can figure this out. Okay, zinc, element loose on its own, got to be 0. Monatomic ion, charge on the ion is +2, so that's +2. Zinc 2 plus, this guy's an ion, so this is 2 plus. And iron loose on its own is 0. Okay, so what this means now is we do have a redox reaction. That just made it worse. Okay, because our zinc was 0 and turned into +2, and our iron was +2 and turned into 0. Okay, so can we identify what the processes are that's doing this? Remember, in the oxidation, our oxidation number has to go up. So the zinc part here is the oxidation. Okay, and in the reduction half, the oxidation number has to go down. So there's a +2, and this is 0, so the iron is being reduced. Okay, this is another key skill because what we've just done is figured out the half reactions, and we're going to draw those in a second here. Okay, but this is a redox, and in every redox, you should be able to find the oxidation half and the reduction half, which is what we just did. Okay, now half reactions. When we write the half reactions, they're going to have to be uh, balanced, and we're going to work on balancing in a minute here. Um, but we're going to use the stuff we just figured out. Okay, so we said zinc was oxidized from 0 to 2 plus. So that means our oxidation half is zinc turning into zinc 2 plus. Okay, and to make sure that our charges are balanced, we're going to have to put 2 electrons over here. And the electrons are products because here the electrons are lost by the zinc. So they're given away, so they end up on the product side, right? We have to remember as we're working through things that the charge needs to balance. Okay. It doesn't always have to be 0, but it has to be the same on both sides. So since zinc is 0, zinc 2 plus has to have 2 electrons on the other side. All right, let's look at our reduction half, which we said on the last bit here was the iron is being reduced to iron 0. So our reduction half has iron 2 plus that is being turned into an iron solid. Okay, we need our charges to balance. We have a 0 on the product side. We have a +2 over here, so we're going to need +2 over here. Okay, now one of the keys here, one of the hallmarks, one of the things that has to be true is our half reactions have to add up to give us what the overall reaction is. Okay, this is our overall reaction. So if our half reactions are correct, they'll add up and give us that. So let's add these up and see what happens. Let's draw a straight line. Okay, we're going to add these up. Okay, and when we do this, we can cancel out things that show up on both sides, just like we usually do when we add things together. So the oxidation half has 2 electrons over here, and the reduction half has 2 electrons over there, so they're going to cancel out, which means that overall, when we add this together, we're going to get a zinc solid and an iron 2 plus. There we go, giving us a zinc 2 plus and an iron solid. Okay, not too terrible, I hope. Okay. And you'll see as we get into the balancing videos that this can be a little bit more intense, but it's all the same stuff. So we're just going to work through it. All right. What's next? Agents. Okay, this is where we're going to get confused. Okay. The agents are doing the work. Agents do the work. Okay. Again, this is just one of those things that gets backwards, and we want to try not to have it be backwards. Okay. The agents do the work. So what does that mean? That means our reducing agent does the reduction. Okay, so our reducing agent is really good at giving electrons. Okay, when it gives away its electrons, it gets oxidized. Okay, so you can find what the reducing agent is because it's the thing that gave up its electrons. It's the thing that got oxidized. Okay, so if it lost its electrons, then it's the reducing agent. The oxidizing agent is the exact reverse of this. The oxidizing agent does the oxidation. Okay. Now, because the oxidizing agent does the oxidation, what it's really doing is it's stealing electrons. It is taking electrons, right? So remember, we have to have a transfer of electrons. So anytime if somebody gives electrons, someone has to take them because we're not going to have loose electrons floating around. Okay. Now, because it takes more electrons, it gets reduced. Okay. I found this nice picture and I thought it helped me make sense of this. So hopefully it helps here too. Okay. Reducing agent has electrons at the start and gives them away to the other dude and becomes oxidized. Okay. That is the oxidation half. Whatever loses electrons was oxidized. The other side, we have the oxidizing agent, which takes the electrons and becomes reduced. Okay. However, you can get this in your brain, think through it. Okay. So let's give this a shot. All right. Let's figure out, what do I say here? Identify the half reactions and the agents. So we will figure this out. All right. First, we need oxidation numbers. Copper loose on its own, 0. Silver with a plus charge is +1. Copper here is a +2. And silver over here has no charge, so that's a 0. Okay. Can we figure out what our oxidation half is? Okay. Remember, in the oxidation, your oxidation number has to go up. So copper went from 0 to +2. So that's our oxidation half. Copper solid turns into copper 2 plus aqueous. And for electrons, we have 0 on the left, so we need 2 on the right to make this both sides be 0. Okay. Now the good thing is you only have to figure out one half because then the other half is what's left over. So that means the silver must have been reduced. Okay. So here's our reduction half. We have silver plus that was aqueous, given to be silver solid. And because the plus is on the left, we're going to put electrons over here, and we just need one to balance that out. Okay, those are the half reactions. Okay, notice what I gave you was the balanced overall, and that we need two silvers to balance this out. And we're going to talk about balancing next time, but you can kind of see that this way, right? We have to balance the charge and we have to balance the atoms. So there's two silvers on each side and one copper because the silver has a 1 plus and the copper has a 2 plus. But if we put the twos in here, we have 2, 2, 2, and that is not the lowest whole numbers possible. Okay, so we'll leave it like that. Those are our half reactions. Now that we have the half reactions, we can figure out what is going on. Okay, now look at it. What thing was oxidized? Okay, the oxidation oxidized to copper 2 plus. Copper 2 plus, copper was oxidized to 2 plus. So that means copper is the reducing agent. Okay, on the reduction side, then, right, silver plus got reduced to silver, which means that the silver plus is the oxidizing agent because it took the electron away from copper. So our silver plus is the oxidizing agent. Okay. Something I want us to remember here is that the agents, if I can spell it right, are the reactants. Okay. So they're what's doing the reaction. So they are the reactants and they become oxidized and reduced during the process. Okay. Hopefully this helps. This is one of the more confusing things that we can definitely talk about this um, in person, or if you have questions you want to email me, feel free. And I will catch up with you next time.